Hello everyone. Today I'm going to be coding a spotlight in P5.JS. Let's see here. So what exactly do I mean by a spotlight? I've got an explanation. So basically, in JavaScript or any visual coding, you have a canvas, which is basically a box that you draw on the screen. So let's say this is your canvas. And you can render things to your canvas. Say you want to draw like a picture. So there's your picture. And let's say you want to draw a spotlight around it. So one of the challenges with doing this is, at least with processing or P5.JS, the default shapes are all filled in. So what I mean by that is, if you say like a command to draw a circle or an ellipse, it would fill this part in, but really what you want is to not fill this part in, but fill this part in. So what you want is all this area filled in for a spotlight effect. So what we can do is, there's a command called begin contour, and it's part of begin shape. So here's the command in P5.JS. You can see it kind of has this almost spotlight effect, except it's a square instead of like a circle. So what you can do is draw this outer edge on the edge of your canvas, and then the inner shape can be whatever you want, like a circle, or if you want a different shape, spotlight. One important thing about doing it this way is it has to be going around one way for the outer edge. So the vertices must wind in the opposite direction for the outer shape, and then the inner shape has to go the other way. So for example, if you go clockwise on the outer edge, then on the inner edge you have to go counterclockwise, or vice versa. You could go counterclockwise and then clockwise on the inside. So how can we use this to make a spotlight? So let's say this is our canvas right here. If we draw a rectangle from here to here to here to here clockwise, and then draw an ellipse or a circle somewhere on this canvas. So we do this one clockwise, we'd have to draw this one counterclockwise. Then we could say fill this area, because this is a contour of this shape. But there's something a little bit tricky about doing it this way. So if you go to this begin contour function on P5.JS, you notice that it is not possible to use ellipse or rectangle within this begin contour function. So we're going to have to write our own way of drawing an ellipse to the screen. So here's the challenge. Let's get started with coding. So actually, okay, so how are we going to draw this circle if we can't use the built-in command for drawing? So one way of doing it is to start at a point and then this would be the center of your circle right here. Then you want to go out some distance, some radius of the circle and make a point. And then you change some angle, so you go out some distance here, and then your next point, you go back to this point and then rotate by some angle and then go out the same radius. So here's some angle, and then you make another point, and then you connect these points with a straight line. And then you do that again. And again. And you do this by a fixed angle. Until you get all the way around your circle. It's kind of a bad drawing, but hopefully you get what I mean. So the more, the smaller your angle is here, the more of a exact circle you get. So right now this is just some kind of polygon, right? But the more, the smaller your increments are for your angle, the better results you're going to get. So if there's 360 degrees in a circle, then if you do 360 increments to that circle and your radius is relatively small, you'll get a pretty good result. So let's start coding. So here is a just a blank sketch in P5.JS. So basically, this function setup here is basically setting up the canvas and allowing you to draw, and it only runs once. And this is actually the creation of the canvas. And this is the X size of the canvas, this is the Y size of the canvas. And then this draw function here is what we're going to be drawing to the canvas. So here we're just giving it a gray background. That's what this 220 means. So if we run this, then you can see we get a square canvas of 400 pixels by 400 pixels, and we're making the background gray. So let's see here. What we can do now is make a function that can draw this spotlight. So if we write a function, we can call it spotlight. And okay. All right. So we call it spotlight. And let's see here. Give me a second. Okay. So we call it spotlight, and we need to create the shape that will go around. It'll go around the canvas. So we said earlier we would make a box basically, and it would go around the edge of the canvas. That's what we need to do first. So first, we use the function begin shape. That'll tell P5.JS that we are declaring our own shape. So begin shape is a function, so it gets parentheses. And in this shape, we're going to have 4 vertexes or vertices. So we're going to have one up here, one over here, one here, and one here. And then it'll automatically close it off up here. So we're going to go clockwise, and we need to know what these coordinates are. So the origin is actually right here, this top left corner of our canvas. That is 0.00 on our canvas. So we could say vertex 0, 0. So that draws our first point right here. Then we need to go all the way over here since we're going clockwise. So that would be the width of this canvas. So here's the width, and then the height is still 0. So another vertex. And oops. There. Okay. So width is a keyword for in P5.JS, and what it does is basically it stores this whenever you create a canvas. After you define the initial width or height, well, the width for the width variable, it puts this value in for this keyword width right here. And there's also another one for height. So if we want to get this point next, we can say vertex width comma height. So what that does is it says, okay, we're going to go over to the width of the canvas and then down to the height of the canvas. And height, once again, it stores, it's just like the width variable, it stores how tall the canvas is vertically. So finally, we need to add this point right here. So vertex. This would be when the width or the x position would be 0, and we would have a height of the height of the canvas. Okay, and just for testing purposes, let's run this. So we need to end our shape first. And then if we fill this shape a different color, let's make it black. So fill 0, which is black. So this would fill whatever's inside here, or whatever is whatever shape we make here, black. Let's try it. Oh, I need to call the spotlight function that we made in our draw loop, or else it won't be executed. So spotlight. There we go. So now we have a black screen, and that's great, but we need that circle in order to have the spotlight. So okay, let's make the circle now. So okay. So okay. We're going to use this begin contour function, which is going to allow us to create this right here. So where's my cursor? Okay. Now we say begin contour. It's a function, so it gets parentheses. And we need to draw our first vertex. So how do we do this? Well, going back to this example here, let's say we have a canvas and here is 0, 0, and we want to give the center point to our spotlight. So we want to give it some XY value, and then it would draw, say, a circle. It would draw the spotlight circle. So let's say we give it like this point right here. It would draw the circle at that point. So with our function, what we need to do is add parameters in order to give it, to tell it what point to go to. So in our spotlight function, we can give it an X and a Y. And then as well in spotlight here, we need to tell it whenever we call the spotlight function in draw, we need to tell it where to go. So for now, I'll just say the center of the screen, which we can say width divided by 2, comma height divided by 2. Okay. So now with this begin contour, we can make our first vertex. So I'm going to create a variable for how big the radius is. So I'll call it radius. So let radius, and we'll say the radius for now will be 100 pixels. So with this example, this circle is doing, when we make this, it's going to be doing a lot of the same things over and over and over. And rather than hard coding the program to draw a point, move some angle, and then draw another point, rather than doing that however many times we want, we can make a loop that does that we program it to do once, and then just say do that over until we reach the other side. So how does that work? Let's see here. So okay. If we make a for loop, we're going to have, for loops have an iterator or some variable that they use to keep track of how many times they've looped. So we'll call it I. We'll set it equal to 0 at the beginning. So basically we're creating a variable I, and we're going to use this variable to keep track of how many times we have looped. So if I is less than 360 degrees, then I++. I++ means we're incrementing I, and we're going to increment I until this statement is false, until I is actually equal to or greater than 360. So in this loop, we can make the vertex. So to do that, we can give it the X position. We know we're, okay. Let me back up just a little bit. So we want to translate whatever the spotlight is somewhere along this canvas. So we're going to translate it the X position, comma the Y position. So that's where it's somewhere along in here. Then we need to tell it where exactly to draw each individual point based on the iterator here. So how do we do that? Well, basically, we want it to move over, hold on. Let me go back here. So basically, in our canvas, we're giving it some point, which is what we have here with vertex X, comma Y. So here is X and here is Y. So now we need to start drawing our circle. Since we went clockwise here around the outside, we need to draw it counterclockwise here. So we'll draw the first point here. So we need to basically, here's where all the points start, right here. And we need to move it over to here. So this is one radius. So move it from here to there. So that's what we'll do first. So we've moved to a certain point on the canvas. Then we need to add the radius to each point, or the X and the Y. So we don't just want to add the radius. We also want to go back to explaining explanation. So we don't just want to add the radius, because the next point we want to draw up here. For example, this X distance is not the same as this X distance. So from here to here is not the same as from here to here. As well as this Y distance is not the same as from here to here, then from here to like where it started, basically. So how do we determine which or what we use, like what X or Y positions we use? So an easy way to do this is with trigonometric functions like sine and cosine. So if we multiply the radius by sine and cosine for X and Y, so we'll multiply the X by cosine of some angle. I'll put that in just a second. And the Y by some sine, some angle. Then I'll put that in just a second. Then we can get our desired circle. So what do we put in here? So basically, we need to know how much we're moving for each angle. So if so we're putting this in a loop, so a for loop, and we have our variable I. So at the beginning, I will equal 0. So okay, sine and cosine. Here is the unit circle. Bet you didn't think you'd have to use this ever again since high school, but it's pretty useful. So sine and cosine. If I draw an angle out here and drop a line down to the x-axis, this is the x-axis, this is the y-axis, then here's our angle. Then I get some height and some x distance to make this triangle right here. What sine and cosine do is they return, or they give you, cosine gives you this x distance and sine gives you this y distance. So based on what angle you give it here. Is this backwards? I think it's backwards. It is, isn't it? It is backwards. Hold on, I gotta fix this. I just realized it's backwards. I'm not sure how to fix it. Hold on, I think I know actually. There we go. Okay. Whoops. Okay. Anyway, so what was I saying? Oh, okay. So sine and cosine, based on an angle, they give you a length. And what we want to do is iterate through every angle in a circle. Or in our case, an approximation of a circle. So here's our circle. We'll start here. And then we want to move across some angles until we reach the end, or 360 degrees. So what we need to do is give the sine and cosine functions in our code the iterator, I. The only problem is that in P5.JS, the default unit for sine or cosine or any trigonometric function is radians. So this, if we just put in 360, that would not work very well. So what we can do is convert this to radians. So let's talk about how many radians are in a circle. So if we draw a circle and it has some radius, then we take this radius and wrap it around the circle, and we can say 1, 2, 3, and a little bit to get to the other side. This is where pi comes from. So it's 3.14, or just a little bit. This is what's called 1 radian. So pi. If we want to go the rest of the way around the circle, then it would be 2 pi. So in our code, we can use 2 pi. So let's see here. 2 pi. 2pi is a keyword. It is a constant. And we'll do that for sine and cosine. 2 pi. So there's one more thing we need to do. Currently, what we're doing is, oh, that's my dog. Currently, what we're doing is currently what we're doing is we are putting some point, we're drawing it here, and then the next point we are multiplying by the iterator. So what does that mean? Okay. How do I explain this? We want to give sine and cosine a ratio of we're going to give sine and cosine a ratio of how many times we're iterating through the loop to where we are in the loop right now. So we iterate 360 times through the loop. So I'm going to create a variable. Oops. Let num times. So num times will store how many times we're going through the loop. So basically, to create a ratio, you divide. So now we multiply by I and we divide by num times. Okay, so that's should be all to our loop. Then we have to end the contour. End the contour, and then that should be it. Oh yes, we need to end the shape as well. And we close the shape when we're done. Okay, here we go. We're going to test it, see if it works. What's up? I'm live right now. 0. Although Streamlabs says I have 1. For anyone that's watching this later, my brother's here right now. He's the guy.
Not true. Doesn't exist.
He's the guy on the rock from my latest video, standing on the rock, going like this.
Oh yeah.
Yeah.
No, he doesn't have a brother. He doesn't exist. It's not real. Whatever he says about me, it's not true. If it's good, then it's true.
See ya.
Bye.
He's a good guy. Anyway. What was I doing? Oh, end shape twice. I didn't mean to do that. Okay. Something's not right here. What is wrong? Oh, I think I know what's wrong. So in a canvas, Y is down, right? So what we need to do is put a minus sign right there. There we go. So now we have this this spotlight, which is pretty cool. Let's see here. In our draw loop, what we can do now is put it to the position of the mouse or the mouse cursor. So to do that, we can do mouse X, comma mouse Y, and we have the spotlight, and it can move around, but there's currently just a blank background, and that's kind of boring. So what I'm going to do is add a picture of me to the background so you can actually tell that it's actually working. So in the file here, I'm going to upload a file. It's a picture of me. It's actually the same picture from the thumbnail of this video. Okay. And I have to preload the image. Preload. And I'm going to have a variable that stores the image as well. So let img, which is short for image, and then img equals, I believe it is load image. Yes. And then the name of the image, which is pictureofme.jpg. Okay. Yes. So now if we draw the image, so we call a function called image. The parameters for this is the image, what image you're using. So we're using the img variable, and then the position. So we'll draw it at 0, 0. Yes, so this image is kind of big. So what I'm going to do is constrain it to the width and the height of the canvas. So can't type. All right. There's me. It's it's kind of squished, but let's make the X a little bit bigger. It's like that. That's good. So let me decrease the size of this too. There we go. That's me. And you can see that the spotlight effect is working. And I'm going to increase the radius just a little bit. So actually, what I'm going to do is make the radius a parameter. So we'll give it a position, x, y, and a radius. And then we can get rid of this. And then here, when we call our spotlight function, we can just say the radius, I'll say radius of 200 pixels. That's a pretty big spotlight. I like that. That's good. So yeah, that's pretty much it. This code will be available in the description once the stream ends. If you'd like, you can check it out. And if you want to challenge yourself, I encourage you to try and make different shapes using this technique. So maybe a star-shaped spotlight or a square-shaped spotlight or anything in between. I hope everyone here enjoyed, and I will see you next time.